Okay, let's look at 21. From a point 50 feet in front of a church, so I'm going to draw a line. I'll kind of draw a red line, okay? 50 feet in front of a church, so that's 50 feet. The angles of elevation to the base of the steeple, so there's one there, and there's one there to the base of the steeple and the top of the steeple, are 35 degrees. And then this one right here, I'm just going to draw a little arrow to it, 47 degrees, 40 minutes. Now, if that looks weird, 47 degrees, 40 minutes, if you remember, we've had a problem like this where minutes, it's like you put 40 over 60, like there's 60 minutes in an hour. So 40 over 60 would reduce down to 2/3. So that's 47 and 2/3 degrees. Let's take it as 47.6667. We'll take it out a little way just to get some accuracy, okay? Because I know I'll probably be doing a trig function with this eventually. That angle, that is actually this whole thing right here, okay? It says draw right triangles that give a visual representation of the problem. Label the known and the unknown quantities, and then use a trig function to write an equation involving the unknown quantity and find the height of the steeple. Okay, so we do know, we've got two right triangles. Okay, so the one that's got the 35-degree angle to the base of the steeple, I don't know how high the base of the steeple is. I'll call it H. Okay, but I do know this is 50 feet away from the base. So I could find the height from the base of the building to the base of the steeple. Okay, because if I want the height of the steeple, I'm going to have to subtract this amount out of the height of the whole building. So let me just go ahead and find this. If you think about what trig ratio, this is opposite over adjacent. That would be tangent. Tangent 55 degrees would be H over 50. So if I put this over 1 and cross multiply, I would have height is tangent times 55 degrees. Check calculator mode. It's in radians. Okay. So let me change it over. So 50 tangent of 55 degrees ends up being about 71.407 feet. That's how high this distance is that's green, okay? Now they want to know the height of the steeple, so let me take the other right triangle. What I'm going to do is I'm going to use it to solve from the ground to the top of the steeple, okay? And I know that this is 47.6667 degrees. This is what theta is. I'm just going to label it over here. I'm not even going to try to draw it on the diagram. I still know this is 100 feet away from the building. And the thing about it is, let me call, this is not good for the health of the video that it just did that. I'm going to call this whole height, I'll call it Y or something, okay? If I want to find the bottom of the ground to the top of the steeple, how high that is, that would also be a tangent function. Tangent of that angle, which again I didn't write in on the diagram, but it says 47.6667, is equal to opposite over adjacent. So my total height would be 100 times that tan 47.666667, whatever. I'll just kind of do that. Okay, so that's going to be approximately, let me go ahead and find out what the tangent of that angle is. It's going to be 1, so it's 100 times 1.0977. If I multiply by 100, that's just bumping it over about 2 decimal places, so that's going to be 109.77. That's the total height from the ground to the top of the steeple. If I want to know how high the steeple is, it's just going to be that 109.77 minus the ground to the bottom of the steeple, which this is what we found here, this 71.407. So I can subtract that. Let me do that on my calculator. And we end up getting about 38.36. So let's say that's about 38.4. I guess that's feet high. Tall is that's the height of the steeple right there.